So I just wanted to show you some the exercises that you got on the lesson on Wednesday. Just want to show you some of them. To make R the subject in the formulas, in this one, for example, what this means that we want to write R alone. We want to have R alone on one side. So what we basically do here, O equals 2 pi R, we divide with 2 pi on both sides. So we get R to be equal to O divided by 2 pi, like that. In this one, that's what we looked also at during the lesson, I think. We have A equals pi R squared, and we want to get R alone. We divide first by pi on both sides. We get A over pi equals R squared. What we need to do to get R alone is to take the square root of R. And when we do that, we get square root of A over pi equals R. The reason, I mean, I could write like this plus minus, because normally a quadratic equation like this, we say that it has two solutions. In this example, however, since R represents the radius, and the radius cannot be negative, I put this in a big bracket. I could erase it actually, but okay, if you want to have it there, just to don't forget that you are supposed to write plus minus. Well, okay, but like this. I think we did these two on the lesson. I will move over to. Actually, this was a bad exercise because it's not a formula. It's an equation. So I don't think I should have it there. But okay, make X the subject. If I say to you instead, solve the equation would be a more appropriate thing to say in this one. What we did here was that we cross-multiplied first. So 158 times, we get 158 times sine 39.7 degrees equals X times sine 52 degrees. When you now want to get X alone, remember there's a multiplication sign here. We must divide by sine 52 on both sides, sine 52 degrees. So we get X equal to 158 times sine 39.7 degrees divided by sine 52 degrees. And of course this is, even though it didn't have so much to do with the formulas in making X the subject, for example, but when you work with the sine rule and you want to solve an equation with that, it could happen that you get X in the denominator, and you must know how to handle that situation. We shall look at this also. Make X the subject in this one. We want to write X alone here. Basically, we want to move all the other factors to the other side. So first we can, I don't know what is easiest for you. Do you feel comfortable that I can write, I mean, we have 1 over 2 times all this. So I can write this as 5 times X times sine 42 divided by 2. Because it's like when we multiply a number with a fraction, this number goes up in the numerator. And the 2 now, well, you multiply the 2 to this side, so you get 2a equals 5 times X times sine 42 degrees. We want X alone here, and therefore we divide. Here it's multiplication. To counteract that multiplication, we need to divide by both 5 and sine 42. We must then, of course, do exactly the same on this side. And eventually, these will cancel out, and you get 2a over 5 times sine 42 equals X, like this. In the last question, we had we should make B the subject. Okay, we want to write this B, like B alone. what do? Well, if in this formula we multiply first 2ac on both sides, what is happening then, we must always do the same on both sides. It's very important, it's essential. What is happening now is that you can cancel out 2ac. We first divided by 2ac, then multiplied. They cancel out. So we get 2ac times cos b equals a squared plus c squared minus b squared, like this. Now, we need to get b alone. There are some different ways in which we could do this, but you see also that you have minus b squared here on this side. We would like b to be positive. It would be more convenient for us. So let's say we take plus b squared on both sides. So we have b squared plus 2ac cos b equals a squared plus c squared, like this. We want b squared alone. Here we don't have any b's in these two, so we can take here minus 2ac cos b on both sides. And if I continue up here, now we get b squared equals, first we had a squared plus c squared, and then minus 2ac cos b. Oops. Here, of course, these cancel out, so that's why you only have b squared left on this side. Finally, what we must not forget is that we wanted b alone, not b squared. Exactly. So what we need to do do that is taking the square root of both sides, and then we get square root of a squared plus c squared minus 2ac cos b. Again, of course I could write plus minus in front, but since b is a length, it's a side in a triangle, the length of a side in a triangle, which cannot be negative. So I put like a big bracket around this, or you could just remove it if you want in this case. But normally when you solve a quadratic equation, like for example x to the power 2 equals 25, you must write that x can be both plus minus square root of 25. Sorry, that was not very nice written, but so you understand what I mean. It's just because in this example b is a variable that can't be negative. Thank you.